We are now in the process of finding solution to the partial differential equations. Now we shall solve the given problem is solve dou squared z by dou x dou y equal to 0. Dou x dou y is equal to 0. Let you take this as equation number 1. And equation number 1 is written as dou by dou x of dou z by dou x, dou z by dou y is equal to 0. And integrating this equation with respect to x, integrating with respect to x, the left hand side it will become dou z by dou y. The right hand side 0 has come, and integration of a 0, it is a constant. The constant is a function of y, so an arbitrary function of y. When you are integrating with respect to x, if a 0 comes, the integration of a 0 is a constant, and instead of constant we are writing as an arbitrary function of y. And again integrating, so this will become as dou z is equal to f of y into dou y. Let you take this as equation number 2. Now integrating 2 with respect to y, it is becoming integration of dou z is equal to integration of f of y dou y. So integration of dou z is becoming z, and integration of small f of y into dou y, it will be another function of y, that is written as capital F of y. This you should note here. At the left hand side, integration of small f of y dou y has come. So integrating a function of y with respect to y, and another function will come. It is denoted as capital F of y. Now you are integrating with respect to with respect to y, and finally a constant will be coming, and that is written as g of x. G of x is an arbitrary function of x. So when you are integrating with respect to y, an arbitrary function of x will be coming as a constant. It is not a constant while you are differentiating the function of x. While you are differentiating with respect to y, the function of x might have become 0. So that is the indication g of x has come here. This is the required solution. So the problem number 9, solve dou squared z by dou x squared is equal to sin y. Let you take this as equation number 1, and let you rewrite the equation number 1 as dou by dou x of dou z by dou x. dou z by dou x, which is equal to sin y. This is equation number 2. Now integrating equation number 2 with respect to x, at the left hand side you will get dou z by dou x which is equal to, now you are integrating with respect to x, sin y is treated as a constant, so integration of 1 will come, so it is written as x plus, while you are integrating with respect to x, a arbitrary function f of y will be coming. So let this be equation number 3, and you move the dou x time to the right hand side, so this will become dou z is equal to sin y into x dou x plus f of y into dou y. So integrating again this equation with respect to x, integration of dou z is equal to sin y integration of x dou x plus integration of f of y into dou y, sorry, f of y into dou x. This is not y, this is x. Into dou x. Now the left hand side, integration of dou z is z, sin y is taken as a constant, the integration of x into dx into dou x, integration of x dou x is written as x squared by 2 plus f of y is a constant, integration of 1 dou x is x. Now you are integrating with respect to with respect to x, and when you are integrating with respect to x, an arbitrary function of y will be coming. So this is written as z is equal to x squared by 2 into sin y x into f of y plus e of y is the required solution. Students, we have been given a problem to solve the partial differential equation. Solve dou squared z by dou x squared is equal to a squared z, given that when x is equal to 0, dou z by dou x is equal to a into sin y, and dou z by dou y is equal to 0. The given equation is z dou squared z by dou x squared is equal to a squared z. Assume this equation is a function of x only. Actually z is a function of x comma y, but here to solve the problem, let us first assume z is equal to a function of x only. Now the partial differential equation will become a total differential equation or ordinary differential equation as dou squared z by dou x squared is equal to a squared z will become now d squared z by dx squared minus of a squared z is equal to 0. Students, you have to remember here one step. The standard solution for d squared z by dx squared minus a squared z equal to 0 is z is equal to a into e power ax plus b into e power minus ax. This step you have to remember in your mind. The solution for d squared z by dx squared minus a squared z is equal to 0 is z is equal to a into e power ax plus b into e power minus ax. Don't bother about how the solution is arrived. It is taken as a tool here. But as per the given problem, z is a function of x and y. Now in the solution, there are two arbitrary constants, capital A and capital B have come. Now we have to replace the arbitrary constants A and B by arbitrary functions in the case of solution for partial differential equations. So replace the arbitrary constants A and B by arbitrary functions f of y and phi of y. So we get, replacing a and b by f of y and phi of y, z is equal to f of y into e power ax plus phi of y into e power minus ax. Now we have to start finding solution for this function. So we let us differentiate the equation number 1 partially with respect to x and partially with respect to y. First we shall differentiate the given equation partially with respect to x. That is, dou z by dou x is equal to, you look into the equation number 1 at the right hand side. Now we are differentiating with respect to x. F of y is treated as a constant. The differentiation of e power ax is e power ax. So then you have to differentiate ax once again with respect to x. It is into a. So the differentiation of f of y into e power ax is f of y into e power ax into a. The second term is phi of y into e power minus ax. So here also, since we are differentiating with respect to x, phi of y is treated as a constant. The differentiation of e power minus ax is e power minus ax, and you differentiate minus ax once again, it is minus a. So the differentiation of phi of y into e power minus ax is phi of y into e power minus ax into minus a. Rewriting this equation, dou z by dou x is equal to a into f of y into e power ax minus a into phi of y into e power minus ax. And you look into the conditions given in the problem. Given that when x is equal to 0, dou z by dou x is equal to a into sin y. And the equation dou z, instead of dou in this equation, dou z by, in this equation of dou z by dou x, we can replace dou z by dou x by sin y, and when x is equal to 0, e power ax will become 1. E power minus ax will also become 1 because e power 0 is 1. And the right hand side, a into f of y minus a into phi of y. And all the terms are having a, so you can divide the equation throughout by a. We get sin y is equal to f of y minus phi of y. This is taken as equation number 2. Differentiating 2 with respect to y, we get, look into the equation 2. So we get differentiation of sin y is cos y. It is equal to f dash of y minus phi dash of y. This is taken as equation number 3. And now you look into the equation number 1. Let us now differentiate the equation number 1 with respect to y also we get. So the left hand side is dou z by dou y. The right hand side is e power ax is treated as a constant, the differentiation of f of y is f dash of y. And also in the second term, e power minus ax is a constant, because now we are differentiating with respect to y, and the differentiation of phi of y is phi dash of y. Given, again you look into the given condition, given when x is equal to 0, dou z by dou y is equal to 0. So the equation dou z by dou y is 0. So dou z by, we can replace dou z by dou y 0 is equal to, when x is equal to 0, e power ax will become e power 0, power minus ax will also will become e power minus 0, e power plus 0, and e power minus 0, and e power 0 is equal to 1. And the right hand side of the equation will become f dash of y plus phi dash of y, which is equal to 4. Now you rewrite the given equation below. Given equations, you rewrite the equation number 3 below 4, which is cos y is equal to f dash of y minus phi dash of y. Adding 4 and 3, we get left hand side cos y, right hand side f dash of y plus f dash of y is equal to 2f dash of y. And the second term is phi dash of y minus phi dash of y. They two gets cancelled with each other. Now we know that f dash of y is equal to cos y by 2. F dash of y is equal to cos y by 2. From that equation we are arriving. From the equation, from the page 1, cos y is equal to 2f dash of y. So f dash of y is equal to cos y by 2. Cos y by 2. So f dash of y is written as df of y by dy, which is equal to cos y by 2. Integrating this equation, we get integration of df of y is equal to integration of cos y by 2 into dy. And integration of df of y is equal to f of y. 1 by 2 is a constant. The integration of cos y with respect to y is sin y. And since it is a total differentiation, an arbitrary constant a has been written here. So let this be equation number 5. Similarly, when you subtract, so in this subtract 4 from 3, and we get phi dash of y is equal to minus cos y by 2. So phi dash of y is written as d phi of y divided by dy, which is equal to minus cos y by 2. Integrating, it will become integration of d phi of y is equal to minus of integration cos y by 2 into dy. And the integration of d phi of y is becoming phi of y, and the integration of cos y is sin y, so it is written as minus sin y by 2 plus b, because we are now integrating the total differentiation. So the arbitrary constant b has come here. So you have to note the difference between when you integrate dou x dou y and dy dx dy. So this is the differentiation. In the case of dou x dou y, arbitrary functions will be coming. In the case of dx dy, arbitrary constants will be coming. Now you rewrite the equation number 2 again. Equation number 2 is f of y minus phi of y is equal to sin y. And you look into the equation 5 and 6. So you find out the term, equation number 5 minus 6 gives you. So look into the equation of 5, f of y, and look into the equation of 6 at the left hand side, minus phi of y, which is equal to sin y by 2. At the right hand side, sin y by 2, and in 6 also it is minus of minus will become plus. It is plus sin y by 2. It will become half sin y plus half sin y, which is equal to sin y. And the second term in the equation number 5 is a, plus a has been written, and in the second term the equation number 6 is b, so minus b has written here. Let this be equation number 8. Now you compare the equation number 7 and equation number 8. So in the equation number 7, f of y minus phi of y is equal to sin y, and also in the equation number 8, f of y minus phi of y is equal to sin y plus a minus b. So as per equation number a plus b, equation number 7, in equation number 8, a plus b should a minus b should be equal to 0. A minus b should be equal to 0. From this we can find that a is equal to b. Now you rewrite the equations 5 and 6 as f of y is equal to sin y by 2. A is written as it is. This is taken as equation number 9. And you rewrite the equation number 6. Look into the equation number 6. It is phi of y is equal to minus sin y by 2, and instead of b, since a and b are equal, and instead of b we have written a. Let this be equation number 10, and substituting 9 and 10 in equation number 1. So for your convenience, so from the page number 1, equation number 1 is has been rewritten here. Equation number 1 is z is equal to f of y into e power ax plus phi of y into e power minus ax. So you write the substitution for f of y, it is sin y by 2 plus a into e power ax, and you write the substitution for phi of y. Phi of y, it is minus sin y by 2 plus a into e power minus ax. You take the LCM, this will become sin y plus 2a divided by 2, e power ax has been written as it is. And in the equation number, in the second term, when taking LCM, 2a minus sin y divided by 2 into e power minus ax. And you look into the sin y terms. Sin y is when it is taken outside, so the multiplication will becomes e power ax minus e power minus ax. In the first term we are getting e power ax, in the second term we are getting e power minus ax. Sin y has been taken outside, both the term are having in the denominator 2, so 2 has been written here. Similarly 2a into e power ax minus plus e power minus ax divided by 2, and this is e power ax minus plus e power minus ax divided by 2 is cos h of ax. Cos h of ax, this is a formula. E power ax plus e power minus ax divided by 2 is cos 2a into cos h of ax have been the first term. And sin y into e power ax minus e power minus ax divided by 2 is sin h of ax. So the final solution is 2a into cos h of ax plus sin y into sin h of ax. Now you have to analyze the problem in a different way, simple technique. So given equation is written as a total differentiation, and you are getting a solution from this equation because it is a standard equation in total differentiation. The solution is z equal to a into e power ax plus b into e power minus ax, and z is a function of x and y. So the arbitrary constants will be replaced by arbitrary functions, and z is rewritten as equation number 1, and equation number 1 is differentiated with respect to x and y, and we are getting equation number 2, and equation number 2 is differentiated, and equation number 1 is differentiated once again with respect to y, and we are getting equation number 4. Equation number 4 and 3 are added, we are getting cos y is equal to 2 f dash of y, and you follow the problem, and we are getting the process of getting equation number 6, equation number 7, equation number 5, 6, 7, 8, and the procedurally you have to solve the problem. This may be asked in the university examinations.